Voyager 1, NASA's farthest-traveling spacecraft, continues its astounding adventure through space, superbly sending significant data from the most important regions of the universe for nearly 50 years. This outstanding space probe has revolutionized our perception of space. However, it has recently been sending unsettling data back to Earth, leaving the entire space industry in shock. Are these disturbing snippets of data the result of a technical malfunction or the activities of extraterrestrials? Join us as we uncover the truth behind these dazzling transmissions. Since its inception, specialists have been astonished by the mysteries beyond our celestial boundaries. This curiosity sparked the prominent launches of Voyager 1 and Voyager 2 rockets, among other groundbreaking space missions. These remarkable missions, studied extensively over the years, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5, Voyager 1 followed suit. These twin probes, each weighing a substantial 720 kilograms, comparable to a small car, were launched during a rare alignment of the outer planets. Throughout their phenomenal odyssey, these brave explorers traversed various trajectories and velocities, leading to a pivotal moment on December 15, 1977, when Voyager 1 surpassed its twin due to variations in their paths. From that point forward, Voyager 1 has become an invaluable resource, providing us with a wealth of data and unraveling space-related mysteries. Before delving into Voyager 1's alarming recent discoveries that stunned the space industry, let's revisit the stunning images captured during its historic Jovian imaging mission in 1978. Positioned approximately 265 million kilometers from Earth, Voyager 1 transmitted an extraordinary series of photographs back to Earth. In January 1979, the spacecraft embarked on a remarkable 100-hour attempt to capture mesmerizing time-lapse footage of Jupiter, showcasing 10 rotations of the gas giant. A cornucopia of 3,750 images allowed us to observe Jupiter's dynamic movements in exquisite detail. In the following months, Voyager 1 ventured through Jupiter's moon system, making an astounding discovery: the presence of a faint ring around Jupiter and 2 new moons. These findings were previously unknown, further expanding our understanding of Jupiter's fascinating domain. To ensure a safe journey and prevent a potential collision with Titan, one of Saturn's moons, course corrections were executed. Voyager 1 continued its celestial journey around Saturn, unveiling 4 additional moons: Mimas, Enceladus, Tethys, and Dione. With the completion of the Saturn mission, scientists decided to transition Voyager 1 and Voyager 2 beyond the bounds of our solar system. Traveling through space at an astonishing speed of 325 million kilometers per year, Voyager 1 began a new chapter in January 1990 with the Voyager interstellar mission. During this phase, Voyager 1 captured some of the most iconic photographs in history, celebrating the Sun and most of the planets. Dr. Carl Sagan played a pivotal role in extending the mission's objectives, advocating for one final set of images as a farewell gift to humanity. Against all odds, his relentless determination bore fruit. On February 14, 1990, Voyager 1, positioned 6 billion kilometers from the Sun, embarked on a photographic journey known as the family portrait to capture the iconic, pale blue image of Earth. These incredible photographs, totaling 60, enriched the spacecraft's remarkable collection. During its encounter with Neptune, Voyager 2 achieved an extraordinary feat by recording wind speeds exceeding 13,100 miles per hour, the fastest winds ever recorded in the solar system. As the spacecraft ventured within 280 miles of Neptune's methane-rich atmosphere, it provided unprecedented insights into this distant world. Remarkably, Neptune's largest moon, Triton, was revealed to be one of the coldest objects in the solar system, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as nitrogen gas-spewing ice volcanoes ejecting particles 5 miles into its tenuous atmosphere, further captivated researchers. These discoveries broadened our understanding of the diversity and complexity of celestial bodies in the outer solar system. The achievements of the Voyager twin probes have been nothing short of phenomenal. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons astonished scientists, shattering previous assumptions about these distant worlds. The moons, once thought to be dormant and heavily cratered like Earth's moon, turned out to be brimming with geological activity. Voyager 2 made history in 1986 as the first spacecraft to fly by Uranus, and just 3 years later, it achieved another milestone by flying past Neptune. To this day, it remains the only spacecraft to have undertaken such a journey. As the Voyager spacecraft continued their mission, NASA implemented various measures to extend their operational lifespans. Over the years, unnecessary components and heaters were deactivated to conserve energy, ensuring these resilient explorers could continue their mission into the next decade. Their mission end date is estimated to be around 2030. For the scientists and engineers involved since the very beginning, the conclusion of the Voyager missions will be both a moment of pride and a bittersweet farewell. The dedication and ingenuity of those behind the project have exceeded all expectations. The wealth of data returned by the Voyagers has provided critical insights, fueled countless scientific discoveries, and inspired generations of researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary spacecraft. They were meticulously designed as stable platforms, rotating at a rate over 10 times slower than the hour hand of a clock. This design minimized image blurring as the spacecraft captured pictures and data while hurtling through the vastness of space. Even before reaching the outer planets, their exceptional imaging capabilities began to astound both scientists and the public. Early images of Jupiter, showing swirling clouds and the iconic Great Red Spot, thrilled audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured attention. Io, slightly larger than Earth's moon, was revealed to be the most volcanically active body in the solar system. The spacecraft's instruments detected unusual signals from Io, later confirmed by vivid images of towering volcanic plumes and a surface scarred by volcanic material. One of Io's most prominent volcanoes, Pele, erupted with such force that its plume reached heights several times the elevation of Mount Everest, covering an area nearly the size of France. Although the spacecraft's cameras were eventually shut down to conserve power and memory before their interstellar journey, it is important to note that their photographic data did not include Mercury and Mars for various reasons. Beyond Voyager 1 and Voyager 2, NASA has also operated other notable spacecraft like Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 surpassed Pioneer 10 on February 17, 1998, marking the moment it became the farthest traveling spacecraft. Voyager 1 continued its solo journey for another 14 years before finally entering interstellar space on August 25, 2012. Although no other spacecraft was in sight, NASA did not publicly announce this historic achievement until 2013. The success of the Voyager missions was achieved through a brilliant technique known as gravity assist maneuvers. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their grand tour of the solar system. Instead of relying solely on their propulsion systems, the spacecraft performed a cosmic dance with some of the solar system's heavyweights. This intricate choreography allowed them to harness the immense gravitational force of these giants, slingshotting them along their paths and saving precious fuel while gaining the velocity needed to visit multiple destinations. As the years passed, data sent back by Voyager 1 revealed new insights into the universe in ways no one could have predicted when the mission first began. However, recent transmissions from the spacecraft have sparked a wave of concern and intrigue among scientists. These signals, first detected in the outer reaches of the solar system, display irregularities that have baffled even the most seasoned experts. In mid-2023, signals from Voyager 1 began deviating from expected patterns. The spacecraft, which had been dormant for years, suddenly started transmitting at higher frequencies. The signals were erratic, as if something or someone was attempting to communicate. Initially, NASA attributed the signals to a technical malfunction or interference from deep space radiation. However, as the transmissions became more coherent and distinct, a new possibility emerged. The signals might not be originating from the spacecraft's instruments at all. Could these transmissions be evidence of extraterrestrial activity? The idea of contact with intelligent alien life has always been an intriguing concept in space exploration. While most scientists remain skeptical, the unexplained nature of these signals has sparked intense speculation. Some suggest the signals might be emanating from a previously unknown deep space phenomenon, such as a rogue planet or a nearby star emitting unusual waves. Others believe they could result from cosmic radiation interacting with the spacecraft's sensors in unprecedented ways. Yet, another theory suggests an even more thrilling possibility. What if these signals are the result of intelligent extraterrestrial life attempting to reach out to us, or, more specifically, to the Voyager spacecraft? After all, Voyager 1 has been journeying through the vast emptiness of space for nearly 50 years. It is conceivable that its long voyage has drawn the attention of another civilization, one that has been observing its movements across the stars. Radio astronomers are now analyzing the signals using advanced equipment to determine their origin. Scientists are scouring the data for patterns that might indicate a language or form of communication from an extraterrestrial source. The discovery of these enigmatic signals has reignited public interest in space exploration and the search for alien life. The possibility that we may not be alone in the universe is both exhilarating and humbling, fueling a new era of scientific inquiry. If these signals are indeed a form of communication, deciphering their meaning could mark one of humanity's most significant achievements. It would bridge the gap between civilizations and usher in an unprecedented era of discovery and collaboration. However, the challenges are immense. Interpreting extraterrestrial signals involves navigating an entirely unfamiliar system of logic, symbols, or methods of communication. Unlike human languages, which share common cognitive roots, alien communication might be based on principles we have yet to conceive. Scientists are approaching the task with caution, meticulously ruling out potential false positives and ensuring the integrity of their analysis. In the meantime, Voyager 1's mysterious signals have also drawn attention to another poignant aspect of its mission, the Golden Record. Carried aboard both Voyager spacecraft, these records were designed as a time capsule, containing a wealth of information about Earth and humanity. The Golden Records include a selection of music, greetings in 55 different languages, sounds of nature, and a pictorial guide to understanding the information. Curated by a team led by Carl Sagan, these records serve as a message in a bottle, intended for any extraterrestrial civilization that might encounter the spacecraft. Could it be that an alien intelligence has found Voyager 1 and is responding to its golden message? The thought is as thrilling as it is humbling, sparking debates about humanity's role in the cosmos and the potential consequences of first contact. While the scientific community remains divided on the origin of these signals, the broader public has embraced the mystery with enthusiasm. Artists, writers, and filmmakers have found inspiration in the idea of an alien reply, weaving it into creative works that explore humanity's place in the universe.